खूप कमी येतोय.
ओके, नाही आता मी लांब होतो माईकपासून. ओके, नो प्रॉब्लेम. So shall we start?
Yes, we will.
Okay, so very good afternoon to all. And today I welcome Nilesh Kanade. He is alumni of Instrumentation and Control Department. He is having 15 years of experience in senior sales and support MNC Tech Group. So he's a junior sales manager in 2017 to 18. So he's ex EM Technic India Private Limited. He joined as a sales manager. Um, then in 2008 to 2011, he had joined as a sales and support engineer in gas liquid analyzer systems. He is a student of Savitribai Phule University in 2018 to 2020, and he has completed his bachelor degree he's completed his master of business administration in 2018 to 2020, and he has completed his bachelor degree in 2008. So now I welcome Nilesh from the half of the Department of Instrumentation and Control Engineering and Pravara Rule Engineering College, Loni. So I hope Nilesh will guide our student about the gas analyzers and their applications. So now I request to Nilesh Kanade to start the session.
Yes, thanks for the introduction, and thanks for giving me this opportunity to present the gas analyzer seminar. So good afternoon to all my friends. So today I will provide you some small information about the gas analyzer and their applications. So the gas analyzer is, as all we are all from the instrumentation field. In the process industries, the process any production or any process industries having the so many instruments on the field, and that all measurement instruments are providing equipments are providing the data to the control system. So based upon that inputs, that control system takes the decision and process executes. So all we are familiar with this process, temperature, flow. These are the field instruments. Apart from that, also the for analytics side, there is a gas analyzers and liquid analyzers are there. They are also providing the analysis outputs, means reports to the control system, and with the help of that inputs, the control system takes the decision, and they execute the process. So I'm working since 2008 in this gas analytical field. So this I will start my presentation with this slide. Hope you can able to see the presentation video and that information. So if anyone could not see, please let me know. Hope anyone could able to see this presentation.
Yeah, yeah, it is visible.
Desktop. Yes.
Yeah, it is visible.
Okay. So we will start with this. This session is nothing but the small information for the gas analyzers and its application. So what is the gas analyzer? The gas analyzer is nothing but it is kind of the field instruments. As like the pressure, temperature, flow measuring devices, a gas analyzer is also the kind of the device, but it is in the very complex form, because the gas analyzer have to handle measure the analytics parameters of the process gases or liquids. So it is the instruments that is capable of analyzing the species of chemicals gas presents in the process gas samples. It is actually it is analyzing the any gases. The gases are made up of different mixtures of gases. Like in our atmosphere, what we are breathing in, that is the combination of the mixture of the oxygen, nitrogen, carbon dioxide, carbon monoxide, and other pollutant gases. So this is the mixture of our breathing air. So likewise in the industries also, there are the some gases coming out from the process while any reaction happens. So that process gas also have to analyze, and based upon this analysis, production process or any process completes. So this works handled by the gas analyzers. So it is identify the species and also can gives the measurement values of the quantity which is displayed either or in numerical, in percentage, or show it is in graphical. It is kind of the small sensor inbuilt inside the equipment with computer and mechanical hardware. It is the mixture of the, you can say it is the instrumentation, computer, and mechanical. Depending upon the type of the principle, there are the different kinds of measuring principles of gas analyzers. These are the basic principles. Actually, these measuring principles we have already included in our this instrumentation syllabus. In 2008 2007 we have this into the analytical instrumentation. There are the few measuring principles I have listed over here. That is thermal conductivity kind of gas analyzers, paramagnetic gas analyzers. The name itself is the measuring principle. The thermal conductivity is the property of the gas. So based upon that property, the sensors are built in the sensor manufacturing facilities. So these paramagnetic gas analyzers, zirconia oxygen analyzers, non-dispersive infrared gas analyzers, the gas chromatography that is well known in the market, and new one is the tunable diode laser spectroscopy. Another one is the chemiluminescence property and flame ionization detection. These are the few majorly used process gas analyzer measuring sensors. And these sensors that industries, some renowned manufacturer are combine this sensor into the one of their equipment, and they forms the gas analyzer. So we try to overlook about the measuring principle, what are these, and then we will go for their applications, and then we will discuss on this. So first one is the thermal conductivity analyzer. It is kind of the sensor which is purely built on the gas property, because some of the gases having the property to carry the heat. So the different gases have the capacity to carry the heat. So based upon that thermal conductivity rate of the gas, the sensor has built, and this sensors works on that principle. And those gases having the higher thermal conductivity carrying a rate, these gases are only measured into this gas thermal conductivity analyzers. So this is the just a small information about the sensor built up. There are the 4 types of the heating elements. Out of the 2 heating elements are in the constant heat generation with the constant current, and across the 2, these are the reference one, they are having the samples. When we provide any gas to these reference elements, the gases takes out the heat from this chamber, and whatever the rate of the heat which is they takes out, and whatever the current is required to build the heat again, that current is proportional with the gas analyzer. Now here is the whatever the signals which is coming out from these sensors are modified, amplified, and tuned with the help of the amplifiers, that are all our instrumentation amplifiers. So it is a kind of the embedded technology also used in this kind of the sensors. So the temperature changes cause the resistance change, and since the filaments are arranged in a Wheatstone bridge, that resistance changes can be converted to the electrical current, and that is available as an output signal. So this is just the diagram of the circuit, and this is the physical sensor, how it looks. It is built inside the analyzer. These are the thermal conductivity properties of the some of the gases. So these are the some of the gases which are usually measured into the industries with the help of thermal conductivity analyzer. So out of that, if you see, the hydrogen is having the highest thermal conductivity. So the thermal conductivity based analyzers are mostly useful for the hydrogen measurements. This is the very explosive gas and very useful gas into the power generation. While the power generation, whatever the transformer, whatever the heat is generating from these transformers, and these transformers are cooled by the hydrogen gases. So this is the specifically used for the hydrogen. Apart from this, other gases having their other thermal conductivity properties. So based upon the mixture of the gases, these sensors are used to measure these different kind of the gases. So usually the applications of this kind of the analyzers are into the thermal conductivity analyzers have the wide applications in the industries where the desirable to analyze the two gas mixtures. So if the gas is having the two gases only, like hydrogen and nitrogen, hydrogen, helium, oxygen, nitrogen. So out of that, though any one gas can be identified and measured with the help of this kind of the analyzers. So hydrogen that is approximately the 7 times greater than that of nitrogen. So the small change are radially detected. So the helium is the only other gas with the thermal conductivity comparable with the that of the hydrogen. And other gases that may be measured using the techniques like carbon dioxide, oxygen, argon, methane. This is all the just the information for you guys, that after the instrumentation you may have the possibility to enter into the analytical instrumentation. And nowadays, because of there are the very big projects are going on worldwide, the analytical instrumentation engineers having the demandings into the in that field. We all know about this DCS control, PLCs, and the field instrumentation. Parallelly, there are now gas analytics and analytical instrumentation is also having the same weightage into the market, and it is the most demanding field now. So another one is the paramagnetic type of gas analyzer. This is also the kind of the measuring principle. In this kind of the measuring principle, the gases, those gases having the paramagnetic properties, like as a magnetic susceptibility. So the gases having the magnetic property, they are producing the magnetic field. So for this kind of the gases, for the measurement of these gases, this paramagnetic type of sensors are built and these analyzers are used. Mostly these paramagnetic type of gas analyzer are mostly used for the oxygen gas mixtures, because the oxygen having the highest magnetic susceptibility criteria. The principle of instruments of measurement of the gas concentration is depending upon the force by which the paramagnetic substance is attracted toward the field of higher magnetic intensity. So it is the kind of the equipment. So this is just the information about this, how the sensors are built. In that sensors, there is the two spheres of glass spheres are mounted between the magnetic poles, and the gases are passing through these poles. When these spheres are deflect from their position is based upon the gas magnetic property. That gas provides the magnetic force onto this sphere, and they try to deflect this glass balls. And whatever the current required to retain the position of the glass balls is proportional with the gas concentration. Again, whatever the milliamps, millivolt or capacitance signals which is generated from the any sensor, it is again modified with the help of the instrumentation analyzers, and it is with the help of the embedded technology. The signals are modified and then used for the measurable readings. This is just the information. This is the actual insights of this paramagnetic sensor. The detector does not have the heating parts. The important of this kind of the analyzer is that it is not the heating part. So because of the it is without heating, this kind of the sensors can be used for the suitable for measuring the oxygen in the flammable gases. Mostly this kind of the analyzers are play the most important role in the process industry or oil and gas industries, where the hazardous gas mixtures are being produced or emissions. So it is very small size and easy to handle and usable with the wide range of the power supplies. And another one is the very famous zirconia oxygen analyzer sensors. This is readily used into the market, and this zirconia sensors is installed in our four-wheelers emission system as well, based upon the oxygen concentration in our four-wheeler vehicle output. Our engine carburetor decides the fuel injection. So this is also the another principle of measurement. The zirconia sensors are works with the capacitive measurements. When the zirconium oxide layers are heated up to the 750 degrees centigrade, there starts the ionization. And when any gas passing from this zirconia oxide metal layers that carries the ions along with this, and this ion transform from the one pole to another pole. It creates the potential difference. It creates the millivolt signal, and that millivolt signal again processed with the help of instrumentation and amplifier, and that is usable for the measurement of the oxygen gas. It is the directly proportional with the oxygen gas concentration. Another one measuring principle is the non-dispersive infrared gas analyzer. It is kind of the spectroscopic kind of the measuring principle. Into that, hope you know about that. In the spectroscopy, that every gas have their filtration capacity. Every gas have the nanomicron or nanometers filters inbuilt. Means with the specific wavelengths, gases absorb the specific wavelength when they are traveling from the infrared sensors. So based upon that infrared measuring principle, these non-dispersive infrared gas analyzers are built. This is the absorption of the infrared radiation of specific wavelength as it is the passes through the volume of the sample. When you pass the infrared specific wavelength of infrared, the particular gases absorbs that infrared radiations, and whatever the absorption rate of the absorption is directly proportional with the concentration of the gases. This is the simple measuring principle. This is the measurement of the quantities of the gases like the carbon dioxide, carbon monoxide, and sulfur dioxide gases, as well the nitrous oxides, methane, many hydrocarbons, etc. This is just the one of PDF I would like to show you. This is the how the actual sensors are looks like. This is the VTech is German-based company. They are producing the critical sensors for the gas analyzers. And for your information, till the India is growing with the so many industries and R&Ds in India, yet we are not able to manufacture any kind of the sensors. Every sensor in liquid and gas analyzer sensors are being manufactured and US based countries only. So these all our gas analyzer sensors are coming from these US and Europe based companies. This is just the data sheet of this analyzer. Why I want to show you that as an engineer, the instrumentation engineer, these are the some measurement or some data sheet informations are related with our analytical and our basic instrumentation. These are the some of the this kind of the sensors which gases they can measure, and what is the combination, what is the measuring range for that. Usually the gases are measured into the ppm, that is the 10,000 ppm is equal to 1% volume. So the gases are measured into the ppm. If you want to select the any sensor, you have what kind of ranges he can able to measure and what kind of the gases. So in that you can able to see this sensor can measure up to 5,000 ppm of sulfur dioxide, nitrous oxide, and nitrogen oxides. So here you could able to see the data sheet. So in the data sheet itself measure the what kind of the flow rate is required, dimension, weight, and here you will see the linearity, repeatability, long-term stability for the span gas, temperature influence for the zero, temperature influence of span, cross sensitivity. These are the parameters. These are the parameters which we have already studied in our basic instrumentation into the instrument characteristic, accuracy, repeatability, linearity. So these are very important into this sensor and analytical instrumentation. This is just one intention to show that, because this usually we studied this linearity, accuracy, repeatability terms into theoretical form, but they are very important into this analytical and sensor manufacturing industries. So another one, this is just a video for how this is the source of the infrared sensor, and this is the measuring chamber. When the gases pass from this source, so this gas absorbs the particular wavelength, and the whatever the wavelength received at the detector side, it is proportional with the gas concentration. If the source emits the 100% infrared sensor of 490 nanometers, and the gas which is coming contact with the sensor, this radiation, it absorbs the 50%. It means the particular gas present into the sample is the 50%. So likewise, the sensors are working. So you see, the main components of these gas analyzers are like the infrared source, sample chambers, wavelength filters, and the infrared detectors. It is a very another one is the gas chromatography. It is very renowned and very old technology here, and it is very complex technology as well. In the most of the process industries, these gas chromatography measuring principles are used because it can measure the maximum number of the gases in one analyzer. So it depends upon the GC is analytical techniques used to separating the components based upon the primarily on their relative volatility. That is the difference in the liquid vapors equilibrium or liquid materials. This technology used for the gas and liquid as well. So here you could able to see this, the sample which inject into the gas path. So whatever the sample which is coming out from the column up to the end at the detector, you could see that sample splits into the three different molecules. So whatever the molecules which is coming out, that sensors will automatically detect the presence of that molecule, and that gives the reading over here. So in a gas chromatography, you can measure in a single analyzer, you can measure the different kind of the combination of gases. And this gas chromatography is specifically used into the petrochemical industries to analyze the complex petrochemical samples. New one technology is the TDLS technology. This is the tunable diode laser spectroscopy. It is also another kind of the spectroscopy based upon the laser technology. It is very fast and precise technology. Recently, there are development happen into the Europe. Nowadays, earlier days, the lasers was available with the very high power laser. So that's why they could not able to use or not that much friendly to use into the gas analysis, because the gases always have the explosive and corrosive mixtures. So nowadays there are the low power lasers are available, and that is healthy for the gas analyzer and samples. So that's why this is the non-contact type extractive kind of the technology. This technology is measuring concentration of certain species of the methane, water vapors, and many other components. The advantages of this TDLS over the other technologies of concentration measurement, it is ability to achieve very low detection limits. Means it can able to measure the very low, means it is having the very low detection limits. And apart from the concentration, it is also the possible to determine the temperature, pressure, velocity, and mass flux of the gas under the observation. Every time you people see hear on the news that Delhi having the very worst air index, Delhi air could not able to you can inhale into the Diwali session. Wow, on what basis that you can tell that the atmospheric air is not useful for the inhale? It is because of the governments are measuring and analyzing our atmospheric air daily basis on particular locations of every cities. So based upon that ambient air quality monitoring, that governments provides the information through the news that the Delhi air is having the very worst air index. Means in Diwali sessions, when we burn the fire, when we use this fireworks, whatever the emissions coming out from the fireworks, it's mixed into the atmospheric air, and it makes this atmospheric air very dangerous for us. So this is the simple measuring principle. It is very simple and extractive kind of the technology, where into the there is the one transmitter and there is a receiver, and from this transmitter and receiver the gases are passing out, and with this whatever the gases are present in between, they absorbs the this infrared, this tunable diode laser wavelengths, and whatever the wavelengths which is coming out after the absorption, it is directly proportional with this gas concentration. So these are the developments. These are the different kind of the lasers are available into the market. Nowadays, this is the QCL DF type of laser. It is very wide, broad spectrum. So in that, you could able to measure the multiple number of the gases. So now these are the basic technology we have overlooked. So we will just have a short overlook on to the application, because into the in your student phase you could not able to understand, or you could not that much familiar with this kind of. But when you go to the industry, that as an engineer you should at least know about the measuring principles and instruments, measuring principles of the different instruments. So into the industries, there is a very broad and wide spectrum of the gas analyzer available into the industries. Every industry having the so many number of analyzers, and they are particular. These analyzers having the maintenance engineer over there also, and they are very trained, and they are only dedicated for the gas analytical applications. So if you look for the power plant, so in the power plant there is a municipal waste incinerator and the coal power plant. So in this power plant, this is just the information about the structure of the power plant. There are the different points where the gas analyzers plays the very important role. And with the help of these readings coming out from the gas analyzer, complete process is tuned by the DCS. So there are the different kind of the gases like this oxygen and temperature measurement, nitrogen, ammonia measurement, hydrochloric gas measurements, and water measurement. Water in the form of the evaporative state, it is present into the moisture form, it is not the physical water. So in the different sections of the power plant, like the coal silos, there is a carbon monoxide is important, because carbon monoxide is a very explosive gas and poisonous gas as well. And while we are driving our two wheelers and the four wheelers, when the fuel burn, that's petrol and diesel burns, they produce the carbon monoxide gas. And from the silencer of the every vehicle, the gases which coming out, it is the carbon dioxide. Because inside the silencer of our two wheeler and four wheeler, there is a catalyst mesh is installed. When carbon monoxide is in contact with the catalyst mesh, it convert to the carbon dioxide. Because carbon dioxide you could able to inhale, but carbon monoxide is very poisonous and hazardous gas. That's why every automotive engine outlet have the silencer, which is nothing but the catalyst. After the coal mill, into the power plant, there are the different sections like coal silos, coal mills, and these are the different gases over there. It is necessary to measure. This is the combustion chambers where they have to measure the oxygen, air preheaters, DNOx stage, before electrofilters and stacks. Oxygens are readily measured because the it is helps to give the fire and explosion. In the fire triangle, if you see, there are the when fire happens, when there is oxygen, any fuel and heat is present over there. So into that fire triangle, the oxygen is also the critical component. So that's why every industry, the oxygen measurement is also important. If you see the metallurgical industries like iron and steel industries, in the mining and steel makings, they are also the, because this iron and the steel industries, it is related with the high temperature, very high dust load, and hot gases often come out from this process. So that's why the carbon monoxide and oxygen and hydrogen fluoride gases are needs to be more major into this industry. But these all measurements are happen because of the gas analyzers. So here is one example. One of the iron industry, because of the gas analyzer was failure during the process, carbon monoxide was built up inside the iron mill, and that happens the explosion. So this is the pipe technician killed by the coke oven gas. This is the pipe explosion incident happened into the one of the steel industry. So this is the picture of this gas analyzer panels. If you could able to see this picture, Here is the electric furnace over here. Whatever the blue lines or blue arrows in between, you have to take out the sample from here, the gases, and this is the panel mounted over here near to this furnace, and this is the actual panel when it was in the factory. It looks clean and neat, but when you go to the field, there is a heavy dust over there. So in that panel, if you could able to see there is the one analyzer, that is the ABB make analyzer. And with this analyzer, to run this analyzer, there are the number of components are required, because the whatever the gases which is coming out from the process are having the very high temperature, high pressure, high flow, high moisture. So for the gas analyzers or the sensors are not able to handle these high pressure, high temperature, high dust and high moisture. So to condition that sample, you need to design the gas analyzer sampling system according to your analyzer requirement, sample requirement. So there are the number of equipments are required, like as a gas cooler, that is the gas dryer, gas pumps are required, gas filters are required. There are the some moisture detectors, pressure sensors, flow sensors, temperature sensors are need to be installed into that panel. And when the sample get conditioned with very low pressure, very low temperature, with very less moisture content, it feed to your analyzer. This is the complete set of the sampling system with analyzer. So likewise in our heavy vehicles also, the vehicles are shipped, and our railway engines, diesel fire railway engines, and our vehicles like are running onto the carbon, our diesel engines, diesel fuel. So with after burning of this diesel, there are the heavy means mercury is also coming out, and along with this nitrous oxide, carbon dioxide, oxygen, these gases are also coming out. So in the heavy industries nowadays, the government has launched the BS6 vehicles. With these BS6 vehicles, that manufacturer of the vehicle have to install the sensors at the exhaust of the any exhaust of the vehicle. So there are the specific DeNOx catalyzers, means nowadays along with these trucks, any diesel engines, there is another separate assembly is also installed, which is dosing the urea. If you could see on the highways, there are the boards display over here. They are saying that urea is available. So that is the urea is nothing but it is the dosing at the exhaust of the heavy vehicle, which neutralize the carbon dioxide and this ammonia, the nitrous oxide, and that urea helps to convert that nitrous oxide into the nitrogen. That converts the nitrous oxide into the nitrogen. So this is the nowadays BS6 vehicles and are adapted with this system. Here you could see this the has developed their system, and this system is installed in the trucks. So here is the urea dosing is going on with this exhaust of the vehicle, and here is the selective catalyst reactor, and these converters are being used, and that converters converts the nitrous oxide into the ammonia, nitrogen. And here is the sensor. If you could see, there is a temperature sensor and nitrous oxide sensors. So here is the some information about the gas analyzer data sheet, just to have the for your information. Here is the So this is the analyzers are looks like. This is the equipments, physical equipment, which is having the display. On that display, it will give the measurement component readings, the name of the components like carbon dioxide, whatever the measurements values in percentage or ppm. Along with the equipments also gives the output in the form of the digital output like 0 to 1 volt for the range and 4 to 20 milliamps. So this is just the data sheet for your information, which is manufactured by our company MNC Tech Group. And what kind of the analyzer it is, there are some specification, which kind of the sensors you could able to install into that analyzer, like paramagnetic oxygen sensor, zirconia, electrochemical, thermal conductivity, NDIR, NDUV, and chemiluminescence. These are the specification of the equipments. And for the specification, study of the specification, use of this equipment, the instrumentation engineers are required into the industry. Because in our study, in our syllabus, we comes into the contact with the embedded technology, computer technology, analytical and process instrumentation, and there's some parts of the mechanical as well. So this is the kind of the mechatronic. In the other countries, the instrumentation is known as a mechatronics. So instrumentation engineers are really useful into the analytical industries. They could able to understand these products easily. This is the data sheet of one of our equipment. Here you could able to see the Ethernet connection. USB means this device are works with this communication protocols like Ethernet. USBs are also available. What are the inputs you can connect? These are the outputs of the device into the form of the 4 to 20 million. What is the power supply is required? 24 plus 24 minus. This is the power supply specification. If any other ancillary sensors are required, this is the data sheet of the equipment. What is the dimension of that equipment? What is the specification, weight? And this is the into the technical data sheet. You could see what is the flow rate is required, what is the response time. Again, here is the what kind of the display, 7-segment resistive color touchscreen display. What is the kind of the outputs, relay outputs, digital outputs? What is the kind of the interface these equipments can handle? What is the kind of the communication protocol, Modbus and TCP/IP, AK protocol? What is the storage temperature of this equipment? Because these analyzers are not readily mount onto the field. They need the air conditioned rooms to work properly. What is the power consumption of that equipment? What standards have to follow, like IP40 and case protection, IP65 electrical standards, under which electrical standard this equipment is being manufactured. And here you could see this different kind of the oxygen measurement, different kind of the sensors you can able to build inside the analyzer. Here again you can see what is the noise, what is the linearity, what is the accuracy. These terms are very important in this kind of the industries and this equipment. Here is the thermal conductivity again, chemiluminescence. And here I would like to show you what is the documentation. If any instrument, if any order comes to this project companies, what is the role and how the documentation how to prepare for that. Now here we have take the one example. There is the one steam equipments, my earlier company. We have built the system for the, our customer was the Honeywell Automation India Limited, and the end users is like the MRPL Mangalore Refinery. So what is the project? That is the Mangalore Refinery petrochemical project. This is the documentation we have provided for the approval purpose only. So here is the covering letter. What kind of how the documentation looks like. This is the purpose to just show you how the engineer have to work on the project. This is the documentation. Who has prepared? Who was the marketing department? Covering letter. Then project is the Mangalore drawing and documentation for approval. In the project stage, every project, engineering project stage, you have to prepare the approval documents first. This is the approval document. Now the end user, every document have their standard, how to write the document in a proper way, because these standards are follow all industries in the project industries. So here you could see into the index what are they included into that. Now if you see, every document have their naming structure. This is the tagging. You can say this is the tag of the document. What is the document tag? Where is the share? How many sheets are there? What is the name? That is the title of that sheet. And this is the revision 0, 1, 2, 3 revision. Now this is for the approval and at what date that document was produced. So in that particular format, the documentation how to prepare for any projects. So here are the different tags. These are the different tags, and for that every tag have the specific titles. So the engineers could able to see or they can able to find out the information about that project. Now this is the PNID, that is the process and instrumentation diagrams for the sampling system. Now this is the one of the kind of the liquid analyzer project. Into that steam and water analysis what needs to happen. So now this is the PNID. You at this stage you not able to understand the, but it is, this is the part of the project. Here you have to prepare the PNID into the AutoCAD, and with this all information you need to fill up into that. If you could able to see, here are the process uh, diagrams, like the how the walls have to show into the diagram. Here is the how the walls have to show, how the lines, how the coolers, every product, every item have the specific information into the AutoCAD and the standard into the engineering standard. Accordingly that you have to pick up that drawing and join as per the sampling system flow. This is the general arrangement and foundation drawing. Means how this equipment looks like, what is the overall dimension of that equipment, what is the length, breadth, height, everything you have to prepare before the actual physical integration. So for that engineers are need to analyze, and they could able to imagine, they have to imagine how our equipment looks if we assemble the number of equipment into the panel. So this is the kind of the arrangement. For that the engineers are required into the projects. So here is the what is the diagram, this is the GA drawing, this is the naming of the any particular sheet, this is the standard formats. Now here is also the general arrangement diagram, this is the foundation.
Nilesh, PPT is
Yes.
not moving forward.
Yes sir,
PPT पुढे जात नाही.
PPT जात नाही ना.
Okay.
ही last slide होती सर.
Before that,
ही slide होती general.
अच्छा. Okay. Okay.
This was I have to just present to know the students what actual work they have to do when
Yes.
they go into the project field.
Okay.
This was just the information from my side.
Yeah. So
Hopefully you all could able to understand some percentage of that information, because at this stage it is very difficult to understand this gas analyzer until and unless you don't have the hands-on experience.
so very nice
So,
presentation given
thanks,
by you.
this
Any question from the student? Hello.
No, sir.
Okay. So Nilesh, hello.
Yes sir.
So whether this analyzer used in building automation?
In building automation, yes, these analyzers are rarely used. If you in the building automation as well, and even in the medical field also, there are also the analyzers for the, like as a blood analyzer, the measuring principles. Because in that slide, if you see the starting slides, like measuring principle of analyzers are the same, only they are built according to that industry standards. So now I am working into the oil and gas field. So that's why these analyzers specifications are different. And in building automations are also having the ambient air quality analyzers. Like into the building automation, you need to monitor the oxygen concentration, carbon dioxide, means inside the room, whatever the gases are present over there. So that needs the analyzer and detectors.
Okay. So lot of gas analyzers you have explained, and their application also we have discussed. So I think all the students will get understood this topic, and that is very important. Okay. So
And this is
right now there is elective
small
subject.
introduction.
Yeah, there is elective subject for our student, that is analytical instrumentations.
Okay.
Yeah. So whatever the analyzer we have discussed in this session, okay, all these analyzers are available in that subject.
Okay.
Okay, so definitely student will understood this, and will get the knowledge about the analyzers and then applications. So I'm very much thankful to Nilesh for sparing your valuable time, even in the busy schedule. So you have spare your valuable time for our students. So I hope the same coordinations will be in the future also.
Sure, sir.
Yeah. So from the department, on behalf of the department and the college, Pravara Rule Engineering College, Loni Instrumentation and Control Department, I'm very much thankful to Nilesh Kanade for sparing his valuable time. Thank you. Thank you to all.
Thank you, sir.
Yeah. Thank you, Nilesh.